So in RISC-V instruction type, in a single cycle, we have to understand that R type has these many. That means we have to learn this. What I'll show you. We have to learn this final. How we will draw this, right? We have to learn this, but in order to learn this, the main thing that you have to understand is this, which was actually the part of module 1. But since the module 1 has not been covered by me in this channel, what I will do is that if you want, okay, of course I will do the module 1. What I am going to do right now is that I will give the things which is needed for our module 2. So first of all, we have to know that we have different type of instruction, like R type is there, I type is there, S type is there, B type is there, U type, J type. These are the different type of instructions which is there. So for each of these instructions, what you have to do is that if I'm taking R type, you have to understand that, okay, you have R type here. Okay, so I will just understand to you one scenario I want to talk here right now. I feel like maybe one scenario I will explain here. I am writing an instruction like add RD comma RS1 RS2. That means the values in RS1 R2 are added and it is given to RD. This is the instruction which is human readable form. But how can you tell it to the computer is that if you are adding and storing the result in the RD, this is we can understand by seeing this instruction, but the computer won't understand this instruction. So we have to convert this instruction into what? The machine language. So how we are going to convert it to the machine language is what we are going to learn first. So this instruction that you have right now, you have to convert it into its binary format first of all, and that binary is converted to hexadecimal. Okay, binary is converted to hexadecimal, and that is known as, that hexadecimal that you got is the machine language actually. So for each instruction there is a different way you have to write its binary form. For example, for R type, if you consider, for R type if you are considering for R type if you are considering, you can see here this is one instruction, add RD RS1 RS2. okay, this is the way in which you have to write the binary code. That is, you need a function 7. I will say what is function 7 and function 3. First, we know what is RS2 and RS1. RS2 is here, this number here, RS2, which you have to represent in 5 bits. So the RS2 5 bits you have to give here. Now RS1 will represent this number here in 5 bits. You have to write it here. Now what is function 7 and function 3? I will tell. RD, we know it is the register, destination register. Destination register, that is RD, which is 5 bits. And now we have the opcode. Now opcode for all of this instruction, if R type, the opcode for R type is different. For the next instruction, if you take I type the opcode is different. So that means you have to understand that R type's opcode value, something we have to learn by heart. That is 011 0011 is the opcode of R type instruction. Understood? So R type instructions opcode is 0110011. Understood? That you have to learn by heart. So if you have this instruction, add RD RS1 RS2, what I'm going to do is, let me show you what does function 7 and function 3 do. Function 7 contains 7 bit, function 3 contains 3 bit. Function 7 is basically function 3 help us to tell whether addition is used, whether AND is used, for whether shift left logic is used, whether SRA is used, whether subtraction is used, whether OR is used, whether what is used is defined by function 3. Okay, which is 3 bit. So if you see for add, the function 3 value is 000, And for AND, the function 3 value is 1 1 1. And for SLL, the function 3 value is 0 0 1. For like each of these have different function 3 values, and I will teach you how to learn this also, I will tell. Okay, but you can see different. These function 3 value you have to write here. If you have add, then you have to write 0 0 0 in this position, 3 bit. Now why you have function 7? Now why you have function 7? ഇതിൽ കുറച്ചും കൂടി ഉണ്ട്. Why you have function 7? That is what we are going to understand now. If you see subtraction, their value, the function 3 value is 0 0 0. Adds function 3 value is 0 0 0. So both of them have same function 3. So if I am putting 0 0 0, how can processor know whether it is add or subtract? So there comes function 7. For subtraction, for addition, the F7 function 7 value is 7 zeros. But for subtraction, the function 7 value is 0 1 0 0, like that. Similarly, XOR, if you see, their function 3 value is 1 1 0 1 0 0. And there was one another who was having the other same thing. It is not here in this example, but I hope you understand why the function 7. Both function 7 and function 3 are basically used for us to know whether which operation is basically used here. Fine. So now let me teach you how can you choose the function 3 values of, how can you learn. Opcode is something actually you have to learn by heart, which I hope you have learned for R type. The opcode is 0 1 1 0 0 1 1. Okay. Okay. Now if you look at here, for R type, this is the function 3 and function 7 table. Okay. Okay, 101. For SRL and SRA, it is like SRL and SRA, if you check, both have same function 3 value 101 101. So whom you choose? So SRA has function 7 values, like how it was for subtraction, right? So you have understood that part, right? R type instruction is what we are going to cover right now. I hope you have understood this part. So function 3 value for add is 0 0 0 and for subtraction is 0 0 0. Now shift left logic, shift left, shift less than, shift left logic, set less than. Actually set less than, actually you don't want to learn. But if you are learning like 0 0 1 0 1 0 0 1 1 1 0 0, if you want to learn in that order, that is why I have written like this. Then you have 1 0 1 1 0 1 1 1 0 1 1 1. So actually we know we will write like, okay, 0 0 0 0 0 1, then you have 0 1 0 0 1 1 1 0 0 1 0 1 1 1 0 1 1 1. This is how we write the flow. So we have to understand, first 0 0 0, first add and subtraction would come, then 0 0 1 comes with shift left logic and shift left logic for 0 0 1. Then 0 1 0 is shift left less than, set less than, okay, and set less than unsigned is 0 1 1, SLTU. So to understand this order only, actually these are not used, but still, okay. Then XOR is 100, then 101 is for 2. SRL and SRA both have shift right logic and shift right arithmetic, both have 101. So we use function 7 to choose between them. Fine. So 101 is over. 110 is for OR, and for AND you have 111. So you know why I given such table is because then only it will be easy for you to understand. Like 0 0 0 0 is 2 times add and sub. Then you have next comes in the number is 0 0 1. 0 0 1 is for shift left logic, and we have 0 1 0 and 0 1 1. This is set left, set less than and set less than unsigned. Then 1 0 0 for XOR, 1 0 1 is 2 for 2, shift right logic and shift right arithmetic. Then OR and AND is what we have left with. So OR would be 1 1 0 1 1 1 is for AND. So if you learn like this, it will be much more easier. This is for 0 0. These are the things which is repeated, otherwise it is the order 0 0 0 0 0 1 0 1 0 0 1 1 1 0 0 1 0 1 1 1 0 1 1 1. We know this order, right? Our binary numbers like 0 1 2 3 4 5 6 7, like it is going in that order: 0 1 2 3 4, this 2 are 5, then 6 7, like that you can learn easily. Okay, this is how you can learn function 3 values easily. So first of all, if I am writing this example, how I can give one fully, how I can write this, let us say if I am writing add RD RS1 RS2, first I will write what? Function 7 value, then I will write what? RS1 value, then what I will write RS2, sorry, first I will write RS2 value, then RS1 value, then I will write function 3, then RD, then opcode. So we know, let us say RS1 has value 5 and RS2 has value 2. Fine. So first is function 7 value. For add, the function 7 value is 7 0. So I write 0 0 0 0 0 0. First 7 bit is that. Then next is RS2. RS2 value is 2. 2 I have to write in 5 bit. 2 I am writing the value of 2 in 5 bit. Okay. So that is going to be 0 1 0. This is 0 1 0 would give us 2 and 0 0. So this gives 2 in 5 bit. Next is RS1. Now I have to write 5 in 5 bit. 1 0 1 0 0. So this is 5 in 5 bit. Fine. Now what? Function 3 value. Add. Add's function 3 value we have learned as 3 zeros. So 0 0. RD. Their sum would be what? 5 plus 2 is what? 7. 7 in 5 bit I have to write. So 7 is 1 1 1, in 5 bit is 0 0. I have write that. Okay, fine. Now we have opcode. Opcode for R type would be what? Opcode for R type we have learned is 0 1 1 0 0 1 1, right? This is what we have learned. This I told you have to learn it by heart. So in this way I write the binary form of this instruction. Now I have to convert this into hexadecimal. How you convert? You take groups of 4 like this. You take groups of 4. Right now I am taking groups of 4. When I take groups of 4, each 4 groups represent one number. How you will calculate that? I will show you here. See, first if the group, first we are taking groups of 4, right? So if I am having 4 zeros, then it is 0. 4 like if this number I got, it is 1. We know how it is. And if I get from 10 onwards, 10 to 15, I have to represent it like A, B, C, D, E, F. This is how I will write it in the machine language format. Understood? So I finally got this binary number, which I convert it to the machine language by converting into hexadecimal. I hope the way. So I hope you understand how you can deal and how you can create a machine language using the R type. Similarly, in the next video we will do for I type, S type, B type, U type and J type. Then we will understand how can you implement it in the single cycle architecture.